So now in this program, we will see how the queues are implemented using Linklist. So as we had already seen in the last program, queues can be implemented using arrays. Now in this program, we will see how the queues are implemented using Linklist. So as we are all aware that the queue implementation of linked lists make use of structures and pointers. So here we are going to declare a structure a node and using structure, and we will be having a data part and there will be a link part. So the link part variable I'm using, it's a struct node pointer. I'm using the name as next. The variable name is next. So this will be our structure node. Now, as we know, this is the syntax of creating a node. Now, as we move on, we will be creating pointers and our node pointers, as well as a new node using this structure node. So we will see it later. Now, moving on to the main. In the main, we are planning to first display the menu and get the choice from the user. So here, using printf statement, we are asking the user to enter the choice. So the menu options will be insertion, deletion, display, and then the last one, we can ask the user to enter the choice. So the choice you can accept in a variable called CX. So depending upon the choice the user has entered, you can start with the case, switch case. Case 1, that is for insertion. Insertion is also known as an enqueue operation, right? So we can name the function as enqueue. We'll be just making a call for enqueue. Then case 2 will be the delete operation. I'm naming it as dequeue. In queues, the enqueue insertion and deletion operations are named as enqueue and dequeue. Then case 3 we will be having the display operation. Then the break statement. Then case 4 will be the default case. For default, we are giving an exception. So any other number other than the case numbers 1, 2, 3, it will be accepted. So this will be our 4 cases. So when you come out of the switch case, so we don't have anything else to display. So we move on to the closing of main and then the function definitions. So when we are going to define the functions, enqueue operation, enqueue, it is not having any return and not having any arguments. So all these 3 functions which you are going to have, dequeue, all the three should be defined above, declared above. So we'll declare. So defining, when we are declaring the functions, you have to end it with a semicolon. So now we are moving on to the definition of NQ. So in NQ, we know that we are going to insert an item. So first we have to ask the user to enter the item to be inserted. We are asserting in a variable. From the item. So before we know that the item to be inserted has to be inserted into a node because it is an implementation of the stack queue using a linked list. So the first thing is we have to declare a pointer of type struct node. So before the ending with a semicolon, we can just declare a new node pointer and then make use of this new node pointer in the struct in order to create a new node. So using the new node pointer, in that address location, we will be creating a new node, right? So using malloc, you can have the using malloc, you can allot space for the new node. So malloc size of struct. So this we are the pointer returned, that we have to make it as struct node pointer of the type struct node pointer. As we all know that malloc will be returning a pointer which can be typecasted to any of the data type. It's a void pointer, right? So that we are returning into new node. Okay, so new node is a pointer of type struct node, and the malloc which is allocating the size of struct node is returning the pointer into the new node pointer. So we have already allotted space for the new node, so we can directly get the item in new node data. Okay. So the new node data will be accepting the value item to be inserted. So after getting the item to be inserted, we will be asking we have to first check whether the new node which we are going to insert is going to be the first node. If friend equal to null, that means if the friend pointer is still pointing towards the null, it's not pointing to any other node, means this is going to be the first node, right? So we are going to make this new node as the first node. So the first thing is we will make friend equal to and rare equal to new node. So both the friend and the rare node will be pointing to rare node will be pointing to the new node, right? And now what is the next thing? So we are making new node as the first node, and one more thing, if you want to make it common, you can just make a new node next, right? New node next equal to none, because then there is no other node, you can just make a new node next equal to none, and both the friend and rare node we are pointing towards none. So this will be the case if the new node is going to be the first node. Else, that means if already nodes are existing, then the rare pointer will be front and rear. If it is the first node, then both front and rear will be pointing to the new node. If it is to be the second node, then the rear pointer, we will be making the rear pointer next. We will be making the new node as the rear pointer next. So in rear pointer next, we will assign the address of new node. So in rear pointer next, we are giving the address of new node, and we will make the new rear node as. So this will be in the else part. So we have taken care of both the cases. If new node is going to be the first node, and if rear node, if new node is going to be the second node, or the second or third node. And now one more thing is, if if the queues are implemented using the rear using an array, we have to take care of the stack overflow condition. Here, as it is implemented using Linklist, there is no case of overflow, because there is we are not declaring the size of the queues as we had done using an array. So we can, as many pre-node spaces are available, we can continue inserting data to the linked list implementation of queues. So this will be the end of insertion. So you can just give a statement that item inserted, right? So after this you can finish, and then after this you can have the coding for DQ. In DQ again we can it is the delete operation. Already we have written, right? So in this DQ operation, we are going to delete an item. So when we are deleting an item, first thing we have to check is whether items are present in the in the queue. So first we have to check if the queue is empty. The condition for queue being empty is if the rear pointer is equal to null, right? If rear pointer is pointing towards null, that means the queue is empty. So we have to just print a message that the queue is queue is empty. Queue underflow. And just return. In else part, that means if nodes are existing, or if the queue has item to be deleted, then what we have to do is you can just declare a temporary pointer that you can do it in here itself. So you can need not use struct node again and again. So you can just declare a pointer called temp of type struct node, and use this temp pointer in order to point to the first node which is going to be deleted, right? Temp equal to print. So it is just copying the address of the pointer print, which is having the address of the first node or the item to be deleted. So in order to delete, what we have to do, we have to make print as print equal to print next, whatever address is there in next point in the next field, we are copying into that, or we are making print as the second node. So this will be the coding for deleting, and after this you can just print a message. Item deleted. So this will be for dequeuing, right? So this is for deletion. If it is not having any item to be deleted, we can just show it. Otherwise, we are copying the address, or we are making So one more thing is, if we are as we are using malloc, we can just free it, right? Free front. Okay. In case if you want to show which item is deleted, you can item percentage d, and then you can just show it over here which item is going to be deleted. So the item which is going to be deleted will be there in temp, right? So that's a temp. This you have to give it before temp data. Okay. So we'll try whether it will work here, because we have already copied the pointer. But if you are deleting it now, if you are freeing using the dynamic memory allocation, it may go off. So we can just cut and paste it over here. I will try whether it will be working here, but still we can just give it over here itself. After copying to 10, we are showing that this data is getting deleted. After that, you can pre-print. Okay. So this is for deletion. So we have finished deletion coding also. Now the next one is for display, right? So we have given the function over here. In display, again, what we have to check whether it is having data to be deleted. So I'm just copy pasting the same code. If array is equal to null, then print underflow else. In else part, we have to show that or we have to delete or we display or traverse through all the nodes and display the item. Again, the same thing, we will be copying the pointer, whatever we have, that we are in the front pointer, whichever node it is pointing to, it is copied into temp, so that using the for loop, or you can just display or using while loop, we can just display that using the while loop, while temp next equal to is not equal to, or temp itself is enough, no? Temp not equal to null. What we have to do, we have to display print percentage d. We are displaying the data. So in temp data, we have the data to be displayed. After that, what we have to do, we have to make temp equal to temp next. So this will continue until all the until the last node, because we started friend, we copied the address of the friend node to temp, and we are traversing through the linked list using the or through the linked list implementation of queue using the statement temp equal to temp next. So this will be the coding for displaying all the data. So in case if you want to give an arrow between the data, we can just give it over here. Okay. So this is for displaying the data. So we'll see how many errors are there. 7 errors. Undefined simple thread. Oh, sorry. We did, after declaring the struct node, you can have all the pointers which we are using here. So star friend, again star array, right? No more errors. So one bracket is missing. So this is while loop bracket and this is else, right? So one more is for the function display. You can give necessary tab spaces or indent it properly. This bracket is for the while and this is for the else. So this will be for our function called display. So similarly you can have it for the other functions. And one more thing is, you can give the clear screen. Just after the declaration, you can just So we'll run it and see. The display, I think I had given small letter T, right? Or it didn't show any error. Okay. Okay. So we will run it and see. I hope errors are over. Only the choice one. Item it means okay. See the some problem is there, no? Like I didn't give